Testing 1, 2, 3. That sounds good for the people in the back? All right, perfect. We're going to try out both. That one works too? Oh, a little staticky, right? Not too bad? Thumbs up over there. It works good? Okay, perfect. Thank you, Yujian. All right, everybody. Thank you so much for joining. My name is Teo Gonzalez. I work over here at Airbyte on our AI initiatives team. You're going to be meeting our lead, Brian, later in one of the panels, but really excited to be welcoming you over here. Love working with Yujian, everything that's going on from OSS for AI. Tonight, you have awesome panels. Just want to give you a little bit more context as to what we do over here at Airbyte, and then we're just going to go ahead and get started. A lot of what you'll hear from Brian's perspective is just how do you think about making data not only available, but also usable for AI use cases. And that's a lot of what we look to do at Airbyte. We believe you have data silos all over the place that have inherent immense value, everything from your APIs and your databases to things you don't even know you have. And we want you to feel empowered to go ahead and leverage that for whatever you can accomplish. So that said, that was really just meant to give you a primer. The stars of the show are going to be our panelists and really our moderator extraordinaire. So Yujian, how about I bring you over here? Welcome again to Airbyte, everybody. Really excited to have you and enjoy the night.
Cool. Hello, everyone. Good to see many of you again. How many of you guys were at the event yesterday? A good, like, 1/4 of you? Cool. All right, so just to give you guys an update, I did break 10,000 followers on LinkedIn, so thank you. Thank you all very much, especially those of you who made multiple accounts to go follow me. Really, really big shout out to you guys. So I'll do a quick housekeeping of some things that I'm doing, and then we'll get into the panels, which are the most important pieces of the event. So first thing is, if you are, am I standing by the QR code? No, okay. If you are looking for some sort of job in open source or AI, and you didn't get a chance to scan this last night, now is your chance to scan this. This is a list of, this is just a Google sheet that I send out to people who ask me for potential candidates. All right. Okay. Oh, I see quite a few phones up. People getting their phones out. One other thing while this is being scanned, I will say, if you take pictures of the event, please tag me on LinkedIn if you post them, or just send them to me via the event. I would love to have the pictures. Yeah. All right. Find me on LinkedIn. Very important. This is how you send me pictures if you do find me. This is how you boost me from 10,000 to 100,000 followers. So we'll see if we can do that next year. All right. Come make a couple extra accounts, This is January 20th. So yesterday we did an event at GitHub. We have another one on the 20th, on January 20th. So if you're going to be in town, come to that one as well. If not, you will get an invitation to it anyway because you attended this event. So on Thursday, I'm going to be doing a virtual event with 9 different speakers, including one from Rohit, who will be part of our first panel, and from Comet, but we're going to have someone different from Comet. We're going to have Gideon from Comet come speak on Thursday. But this is going to be a really good event. There's going to be 9 different companies talking about different verticals, different areas in AI. So if you want to get like a very broad overview of the landscape and you want to understand what's going on, this is the event that you should go to on Thursday. And it's going to be virtual. It's going to be online, so you can turn it on and play it in the background instead of talking during your meetings. And that's it. So we'll have the panelists come up. So our first panelists, our AI and production panelists, are going to be, I'll have to look at my phone. Rohit from Portkey, Brian from Airbyte, and Claire from Comet. So take a seat on the couch. We're going to, where's the other mic? Teo, where's the other mic?
It's on the chair in front of you. Talk gently into that other mic.
So you guys will have the mic here. I'm going to sit here. Is this a table? I think I'm sitting on a table. All right. So we're going to just start with some so this is about 45 minutes. We don't have a timer, so I'm going to put a timer on my phone. Those of you who know me, who have been to my events before, know that I love when things run on time. I'm going to put a timer on here, 45 minutes, and when it beeps, we're going to shut up. All right, so we'll start. Very simple. Claire, since you have the mic, you can be the first to start. Tell us a little bit about yourself. Tell us a little bit about Comet.
Yeah, hey everyone. I don't think this is
The mic's not on. Okay, well, you have to
switch. Yeah. Well, hey everyone. Thanks so much for coming out. My name is Claire Longo. I have a background as a data scientist. I am a mathematician, I guess, by training. I got my bachelor's in applied math and then moved on to get my master's in statistics. So that's kind of the perspective that I'm coming at AI with, is kind of that foundational mathematics. My career has been really interesting. I started as a data scientist and I got really frustrated because I couldn't get my data and I couldn't get my model into production. So I became a machine learning engineer to go solve those problems, and I ended up leading a machine learning engineering team at Twilio for a while. And then I pivoted into startups, and I'm in a kind of an interesting role in startups. I am leading customer success. And the cool thing about this is that all my customers are basically who I used to be in my past life. They're frustrated data scientists or ML engineers building platforms, because I'm working with these ML ops and LM ops tools. So I've got this really cool window to see like what all our customers are building, things like that. And I've seen a lot of models go into production. I've seen a lot of things go right and a lot of things go wrong. And so that's what I'm hoping to share with you all today.
popcorn the mic over. Rohit?
Hey, great to be here. I'm Rohit. I'm the founder of Portkey AI. We're a production platform for GenAI apps. So think AI gateway, guardrails, governance, specifically targeting the mid-market and enterprise companies. We do have a very popular open source AI gateway solutions, so check that out on GitHub sometime. This is my second startup. The first one was acquired. Then I've been in GenAI, starting from the BERT models into GPT-2 all the way to GPT-4. And I realized that productionizing these GenAI applications was probably the hardest part of deploying my applications. And I said that, hey, if enterprises have to go to production with AI, they need the foundational platforms that enable them to do this. So that's sort of the core motivation behind Portkey, and excited to talk more about LLMs in production today.
This is, it is working, okay.
I'm Brian Leonard, working at Airbyte. Previously of a variety of teams here at Airbyte helping our data movement platform happen. Recently the connectors team and our connector builder, as well as the AI initiatives with that. Now I'm working with Teo and others as we're helping people put their AI into production. Hopefully learned something as well, so excited to talk about that. Before that, one of the things I did was pre-robots, created a company to help people get things done called TaskRabbit, which was sort of, pre-AI, so it's almost irrelevant at this point.
TaskRabbit is pretty popular.
Yeah, for like, if it's not a robot,
Okay, cool. So this is the AI production panel. So why don't we start off with Brian, since you have the mic. Tell us something maybe interesting or surprising that you've learned while putting AI into production.
Let's see. While putting AI in production, I learned recently we were decided to scale out an embedding service. So we were doing our own embeddings. Lots of people talk to services like OpenAI to be able to do that, but we thought it's kind of just giving them money. Like we can make this happen. And we get the data, you get all those words, and then you run it through a model, and you take very small words like hi, and you end up with like 7,000 integers or something like that. I don't know exactly what's happening, frankly, but there's a lot of numbers. And we're like, okay, that's great, and it kind of worked. But then we realized that it took a lot of memory, and the code itself wasn't changing that much, and we decided it was better to make our own embedding service over here. But then we realized sometimes it takes a really long time. We were embedding like the entire book of Huckleberry Finn or something like that. Like it was a very long PDF. And then our status check timeout was timing out, and it was shutting down that node, and it didn't work. So we were getting all these unexplained failures. And all this to say, which is like, I don't know, maybe you should use an embedding service from OpenAI or something. But either way, things that seem simple when you once you dive in, you know, there's always more to learn. I guess that's the biggest deal.
OpenAI, if you're watching this, you can sponsor Brian for this placement. All right, Claire, what's something interesting you've learned about putting AI into production?
Yeah, something interesting I learned about putting AI into production. I was actually blown away by how many AI and traditional machine learning models are in production without monitoring. Monitoring, if you're a software engineer, it's a very obvious concept. You would not put software into production without any kind of monitoring or logging. You guys just know that. But coming more from like a mathematics background, analytics, data science, that's not common knowledge. So we're like, look, we built a cool AI system, we built a cool model, and we throw it into production, and then people are like, oh, it's doing weird stuff. Can you debug that? And we're just like, what's that? So that is kind of like a software engineering best practice that really had to be adopted and popularized across both machine learning and AI. I've seen it catch on, but I am also still quite surprised by how many sophisticated, mature systems are in production that maybe don't have full coverage in terms of monitoring. So that's a very interesting area to me. It's an area that I'm very passionate about. I've worked for 2 startups that provide great coverage and products for those kinds of tools. But I've even put models into production and then like retroactively was like, oh, I need to add these monitors. You don't want to do that. You want to think about what could go wrong here. What should I be logging? What metrics should I be tracking before that moves live? And then you've already got like great dashboards set up for that. So you've got visibility into what's going on. So that was definitely my lessons learned. Like I definitely did it wrong the first time and now I'm doing it right.
Very cool. Rohit, tell us a little about what you know what the question is.
Interesting and challenging stuff, right? So I think, so I'll talk about 2 things. One is obviously the nights that you just stay up because of changes that happen. And you know, Brian mentioned this, but you build your own fine tune, you're really happy with the evaluations, and then next day OpenAI has this beautiful new model that completely changes everything again. And you just have to go rebuild everything. And I think I sort of discovered this concept of you now need to be forward compatible. We have to almost accept that changes are going to keep happening. You'll have a better embeddings model, a better chat completions model. So how do you prepare your application to be forward compatible with the new changes that are going to happen and almost assume that it's going to get better, faster, cheaper? So just be prepared for those changes. I think that's obviously one. And I think more interesting anecdote from my previous company was related to logging again. So we were using Datadog for logging, and something that we don't realize is that traditional logs are actually very small in size. They don't go above, you know, a few KBs. But then LLM logs can be insanely long. I mean, you've got these, I mean, if you even make the mistake of logging and embedding, then you're just totally done. Like, just please don't do that. But so, and the traditional logging systems don't work because the underlying infrastructure is not built to support these very large token logs. And so you just need to, so if you're planning to decide, if you're deciding to, you know, just put it into CloudWatch, I can already tell you don't do that. You'll just run up a bill and the finance team's not going to be happy.
Okay, so actually I think this leads into a nice question for Claire. So instead of doing CloudWatch, what are some of the solutions that your team at Comet has implemented to make logging, let's say, better, easier, less expensive?
Yeah, absolutely. I love that question. So I work for Comet, and it is a experiment management and LLM like tracing and observability kind of tool. We work for both traditional ML and LLM's AI, but I'll talk more kind of on the LLM side today, and you'll also see a quick 5-minute demo when I get to it. In terms of what we offer for like the logging, so the first thing you want to log is like the traces. You want to know those inputs and outputs of your AI system, and you want to be able to debug it if something goes wrong. But also to really identify if something's wrong, you need a metric to track, and that's where we offer this really cool framework to create your own custom metrics or use like out-of-the-box metrics for stuff that LLMs do all the time, like hallucination, bias issues, fairness issues, stuff like that. So you have some custom metrics that cover that. Or you're gonna have some traditional metrics that cover all those issues, and then you can also customize it. I'll go into more detail with the demo, but that's really gonna be like a metric you wanna keep an eye on. If the metric does something weird, now you've got the inputs and outputs, you got your traces and your spans, you can actually drill in to see exactly where this thing might be having issues so you can improve it. But don't log your embeddings.
So Brian, we've been touching logs, embeddings, data. Have you seen anyone try to move embeddings or big logs around with Airbyte?
Yeah, I mean, embeddings are built into many databases these days, and pgvector, for example, and DuckDB and ClickHouse and Snowflake and all kinds of places, right? And so we have people, for better or worse, syncing, full tables all the time of those that happen to include embeddings. In the end, what is that, like 7,000 numbers times 4 bytes each? Like, that's fine as long as it's not Datadog. Datadog will charge you like $100 a character or something like that. But like in Snowflake, like that's nothing or something like that. So it's not a huge deal in those movement cases. And case by case may be cheaper than re-embedding them for sure.
Okay, that's very interesting. Since you have the mic, we'll start with you again. What's been like a cool use case that you've seen? What's been your favorite use case that you've seen?
Let's see. So, I mean, there's one that we built that I was super excited about. So, Airbyte has a tool called the Connector Builder. This is we do connectors to APIs, and we've built 400 or so source connectors for various APIs: HubSpot, Salesforce, Pokemon API. But we've got this connector builder thing, and it's kind of like Postman, and so you teach it the endpoints to hit and how they do pagination, authentication, these kinds of things. And people have built 10,000 of those because there's a bunch of crazy stuff out there. The thing that we built recently and launched over the summer was basically you put in a docs URL, the documentation URL, and it reads all of that and auto makes the connector for you. And it's just like crazy powerful to go from nothing to a fully fledged data connector in seconds or minutes. The main learning there is that it's not like there's not hallucinations throughout that whole situation. The real unlock was similar to the unlock, in my opinion, of like GitHub Copilot and VS Code and Cursor and these kinds of things, which is the Copilot approach. So it's not all or nothing. If it's all or nothing, it'll end up being nothing because you pick 9 different things, each one of which is only a 20% chance of failure. Those multiply out, and you're in big trouble. But if it's guiding you the whole way and giving you a preview and all that other stuff, it turned out really successfully.
What are people doing with Pokemon data?
Oh, you gotta understand what Bulbasaur's charisma level is. I don't know what's happening.
I don't know. I'm just messing with you. All right, Claire, what's been your favorite use case you've seen? That's not ClaireBot.
Yeah, it's not ClaireBot. That's not my favorite use case. So actually, I love seeing all these different use cases across these kind of more like enterprise companies. One stood out to me just because it illustrated a very common design pattern across all of these. I saw an insurance company building a AI chatbot to help you file an insurance claim. I think this is awesome. I hate talking on the phone to people about anything. I'll put it off forever. So if you've got that option of just like working with a chatbot to file some paperwork, that's awesome. But the thing that's really illustrated for me is that there are edge cases that you really need to think about when you're building this system. For this one particularly, they had to think of an edge case of like, what if someone's in a terrible car wreck and there's like some kind of like loss of life or something like that. In that situation, you probably don't want to talk to a chatbot. You need to talk to a human because now this is like a human problem. And so they had this really interesting kind of like routing logic in the system to take care of that edge case. And that made me think about like, okay, chatbots are really convenient, but they might not always be the right answer for things that we're trying to do. And we've actually got to make sure that we're accurately capturing that kind of routing logic in these systems. And that's another thing that we have to kind of keep an eye on in production to make sure it's not going wrong. The other thing is like that system, and like every system I've seen, it's never just one call to an LLM. It is so many different steps. You got a retriever step, different embeddings, different routing logic. You've got all these different steps in the system, and each one is a failure point in your system. So these things get really complex, and that definitely like illustrated that for me.
Very cool. Rohit?
I think even I have an insurance use case. Somehow insurance seems to have adopted LLMs quite a bit, right? We assume they're the laggard industry, but this time it's different. But a very interesting use case I saw was, so in Indonesia, the primary policy broker called Koala, they actually had a lot of people paying premiums, and they don't have a proper reconciliation system at the back. So people are just uploading screenshots of mobile phones, computer screens, they're uploading PDFs. So there's a lot of information getting uploaded, and they'd actually written OCR systems for all of these different types, and this kept breaking all the time. So they actually switched to vision models, and they've now created a workflow where they've improved accuracy almost 2x, because vision models are, they're really good, they're fast, and they're able to view content in multiple different file formats, etc. So you don't really need to say, okay, this is the transaction ID, and if there's multiple numbers, the vision model does figure it out really well. So I think that's, seeing that in production and seeing the scale at which they were doing these image scans was just fantastic for me.
Wow, I'm really surprised to hear about the insurance use cases. So something else that came up when you guys were both talking was like this thing like, oh, like there's a lot of failure points along the way. And I think actually I saw you talk about this with the AI gateway at some point, which is like these like fallbacks and whatever. So how did you kind of like go about addressing that problem? And how do you determine like, okay, like one LLM is failing or one LLM call is failing, like when should I go to another LLM? When should I retry? How do I know when to retry? Things like that.
Yeah, I think we don't understand failure as much with LLMs because till now we've dealt with APIs which were only successful or failed, and you could look at the response code and say, okay, this succeeded or this failed. With LLMs, failure is a lot more stochastic, where you have a gradient of failure. Maybe it failed really badly, maybe it didn't fail, maybe it didn't pass some checks that we have. So I think one is identifying the kind of failure, and then if every developer had to go build all of these systems out in their applications, then forget about building the cool insurance applications. You're just building guardrails and all of this stuff. So instead, what we've done is we've said, hey, focus on building your applications. The gateway layer sits between your application and the LLMs. And this gateway can then understand successes and failures and help you define routing logic on top of it. So you can say, if my bias guardrail failed, switch to maybe a more capable model, or redact some of the stuff because I don't want this going back to my user. So I think that level of abstraction is obviously useful, and I see a lot more enterprises now deploying an equivalent of a GenAI gateway to solve a lot of these use cases rather than building all of this and front-loading it within applications. Yeah.
Cool, that makes sense. Rohit, since you have the mic, we're gonna just continue to start with you, and then we'll come this way again for this one. So. This is also related to your last comment about like the vision models and stuff like that. What are you seeing people do with multimodal AI? This is something that last year was pretty hot. People talked about multimodal RAG a lot, but I don't think I've seen a ton of use cases yet. Have you seen anything interesting going on with multimodal AI?
I think it's, I wouldn't say it's anything crazy that's happening with multimodal AI yet, but we do see a lot of interesting image plus audio use cases coming in. So for example, this isn't being recorded, right? Yeah. So DoorDash.
It is.
It is? Okay. Okay, I already said it out. So a publicly listed delivery platform. Yeah, so they're essentially, so they have a lot of these compliance requirements for riders. So whenever they're starting a shift, they have to be like, okay, take a photo. This is my bike. This is my bag. You say something, and so there's a bunch of steps that you have to complete. and they had traditional machine learning models for this, and they're now switching that over to Gen AI so that teams can just build agentic flows on top of it. And that was very interesting to see that you can actually, multimodal AI is probably going to be the thing that connects the real world to LLMs the best, because you're dealing with image data and audio data. I mean, the demos for real-time voice APIs are really, really cool. And almost every customer support team is now experimenting with, can we automate voice support in that fashion, which has just never been possible before. So I'm hoping 2025 is the year when we see a lot more this convergence of real-life use cases and then computer stuff.
Very cool. Claire.
Yeah, I don't have too much to share. I actually have not seen too many multimodal use cases. I would love to, so I'm sure they're coming. I'm still seeing a lot of RAG use cases these days, but everything you said sounds wonderful, so I'm excited for that.
All right, Brian.
We're working with a team, and they're just absolutely, I think rightfully so, obsessed. I don't know if you've seen it with Google Notebook. You can load some stuff in there and get a podcast out. And I swear to, it's better than most of the podcasts I've heard, frankly. Like, maybe because I put the content I wanted to hear, and I don't know. It's hard to say what comes first. But either way, what comes out of this is just tremendous. And so they're like, yeah, you ingested all of our Salesforce data and made a accurate, synopsis of our customer or competitive landscape. But like, can you make it a podcast? And I'm like, working on it, man. I'm working on it, step by step. Anyway, if you haven't tried that, I suggest check it out. It's super cool.
So, do you guys have Airbyte connectors to Notebook LM?
No, not yet. They've got. I didn't look at the APIs, but it's pretty minimalistic. You can just upload files, and so it's a little bit manual, and I don't think there's an API for it. So you have to figure that out. I also believe the team quit last week and are assumably making their own somewhere else. You can check that out too.
All right. Well, that's quite interesting. Yeah. All right. So as we kind of look, I'm going to wrap up with the last couple questions here. Just one more kind of introspective or interesting kind of like technical question, and then maybe some lightning questions, and then we'll open it up to the audience, see if anybody else wants to ask anything. As we move forward in the next couple years, could you tell us what you're most excited to see actually happen as people start really putting AI into production in the next, let's say, 3 years?
It's hard to go first. Where we're at is in a technical revolution, right? I think this is pretty clear. And there's not really that many of them, right? It's kind of like computers, internet, mobile, AI, I think. Right before that, transistors, computers, et cetera, et cetera. And so there was a period in the 70s when it's like, hey, look, a transistor, what can we do? And we get weird kitchen gadgets out of that, right? We're still in that Cambrian explosion, that period of that with AI. I think we're going to find what it's good for and what it's not good for, as well as push the boundaries of that over that time period. And so where we're at right now, even just rolling out that capability everywhere is amazing. Where I think we're at right now is if you give a bunch of documents, RAG style or something like that, to 100 people, if they more or less make the same decisions about that, that's kind of what AI can do right now. So it's good for insurance and finance and lawyers and all these other kinds of things and customer support knowledge bases and all of these kinds of things. And so it's going to get better and better. And most importantly, actually become more hidden when it's just a part of the user experience instead of chatbots or something like that. Yep. Super excited about that.
So you're excited to see AI kind of become behind the scenes?
Yeah, I don't want to see it. I just want my life to be awesome. Just keep that going.
Very cool. Claire?
Yeah, I think that's a really good answer. I think for me, I'm very excited about agents. There's a lot of things that I do day to day that I really want to automate.
I have good news for you.
Yeah.
We have an agents thing after.
Queuing you up. Yeah, I'm very excited about agents and excited to hear about that. because there's things I want to automate. Like there's just a lot of simple tasks that I think we're doing as humans that we shouldn't be spending our time on, and that's where I really want to apply the AI. And I think that's the way to do it. Also, I think that, well, like LLMs are really powerful generative AI. They're language models. I want to kind of explore other kinds of models that could be generative. Vision is definitely one of them, video, but there's maybe other things that could be more powerful, and I don't know what that looks like yet. This is a language brain, and I think we got to keep that in mind as we're building on top of it. But yeah, in general, just agents, like please automate emails for me. I don't even want to read them.
Let me call my agent. He'll talk to your agent.
Yeah, I think so. Short term, obviously, agents being able to take actions and not just summarize stuff and still I have to do this stuff. I mean, just reply for me. That's what I want most times. But I think so those. But I'm also excited about smaller language models fitting into agents, making them a lot more accurate so that the error rate, as Bryant was saying, does not accumulate over the agent run. So how do we create these smaller task-specific, domain-specific models that are extremely accurate, extremely low latency, almost free, but they can only do that one specific task. So how do we get to that? I think that's what I'm excited about. Since you asked 3 years, I think we have seen early glimpses of self-improving systems, where today we can do a lot of stuff in, say, even simple cursor agents, where I can say, hey, find the bug in this code, fix it, and raise a Git commit. And it does work today. I mean, it doesn't do complex bugs, but it can do simple bugs. I mean, this weekend, I added 3,000 lines of code along with test cases to my code repo, and nothing broke. So clearly, I mean, there is possibilities that over the next 3 years, for sure, we'll see self-improving everything, software for sure.
Very cool. So for those of you here who were here last night, all right. Mike. Okay. Those of you who were here last night who saw the GitHub wrap thing, I actually wrote that with AI during the event yesterday. So you guys have seen something now for that. We have a little less than 20 minutes left, so I want to go through a series of quick questions with you guys. Don't go too much in the answer, and we'll open it up to the audience for questions, all right? So if you have questions, get ready. All right, so don't tell me why, but tell me, what is your favorite LLM?
Sonnet.
All right, Claire.
ChatGPT.
Okay. Brian.
ChatGPT. Yeah.
ChatGPT. Okay, very interesting. How many people here prefer ChatGPT as their favorite LLM? Raise your hand. All right, what about Sonnet? Whoa, wow. Okay, any other LLM? If it's another LLM, raise your hand. Okay, so one person likes something other than Claude or so it looks like they really do have a monopoly on here. All right. If you were a type of food, what would you be? And don't tell me why, just tell me the type of food.
Pork vermicelli.
Okay, all right. Claire.
Oh my gosh, I have no idea.
Well, I know what color you would be, but
Yeah,
food
that's
is a bit-
helpful. That's helpful. We can start there. No, I'm gonna take too long with this one. Well, I like to make cookies, so cookies.
Cookies, okay.
I'm not supposed to tell you.
All right, Rohit.
Samosa jumped to my mind, so.
All right, you'd be a samosa. All right, questions from the audience? Yes, sir. I'll run the mic to you.
So the LLM world and AI world has been focused on trying to take all of the knowledge of the world and feed it to the user. How much and how fast will you think will AI in general start to become personalized and adaptive heuristic to what the users are wanting?
Okay, I can take a stab at it first. So I think technically this is going to be a function of how much personal data can I collect and safely use within the LLM. And I think with Claude Desktop and the MCP servers that they're building, which can be completely local, completely private and secure, that's, I think, a good place to start. But the more information that I can pass in as context about you that's relevant to anything that you ask, the more personalized it's going to get. It would have been a lot more personalized already, but there's so many safety and security constraints around this that I don't think anybody wants to take a really big stab at it right now. But that's sort of my perspective.
Yeah, I mean, there's a couple different mechanisms to like personalize an LLM. One is to feed it very personal data. That sounds really dangerous, but also like our data is already out there. So that's something to think about as well. And there's other mechanisms like the RAG architecture is really popular, and that's just a way to kind of like focus the LLM on specific context data. So that's an architecture that's already very popular. And the other one would be learning from its own interactions very quickly, and that's very interesting. That's something I experimented with quite a few months ago, so maybe things are more advanced now, but I wanted it to learn from the conversation that I was having very quickly and then start personalizing to me as I was having that conversation, and I don't really see that happening yet unless there's some new technology I'm not on top of. I don't know. Yeah.
Just one more. Because I know one company, a friend of mine has a company called Ario, heyario.com. And they, the founders from a company that did enterprise data security, so they're pretty serious about these things, but it connects to your Gmail and Amazon and DoorDash and Strava, and it's like using that as context for the LMs, and it's focused on parents, and so it's like summarizing the emails I get from my school, which is kids' school, which is like thousands of them for me, and it's like pretty great. Yeah, check it out.
Other questions from the audience?
Can you guys talk about some of the test-driven development you think about when it comes to writing LLMs? Like Claire, you talked about software engineering practices, but when it comes to writing LLMs, like sure we can have monitoring, but what about writing tests?
I don't think tests and evals are exactly the same thing, but they're both definitely important. I think you've got these knobs on this crazy machine, and you don't really know what the wires look like behind it. And the only way to really understand if you're tweaking them in a direction that works is to say what you want on the other end and compare it, and then have slightly more greens and reds and all this other stuff, as well as feedback from the users. And so like that was super helpful for us when we really focused on that suite, and every pull request automatically got this crazy green and red thing and stuff like that. I think that's amongst other, like we didn't screw up the Python kind of tests, is what I'd recommend.
Yeah, you're asking the right question because these systems are software, and we got to think about it that way because they're live production systems. The approach that I see kind of before, like the tracing and the evals in production, is really somewhat scientific. You're iterating on stuff. You're probably iterating on different prompts. You're iterating, you may be using different models, different parameters on the models. You're tweaking stuff. And when I first did that, I would tweak a few prompts, send some data through, take a look at the output, and be like, looks cool, and move forward. That is not scientific, and that's absolutely not what we should be doing. You've got to run like a true experiment here where you have like a holdout data set so you're not overfitting to your own biases, your own ideas of how the system should work. So the best practice here is really that holdout data set. Let's say you want to compare two different prompts, and so you've got versioning of the prompts, and then you can use an eval metric to actually get a metric that's going to help you compare which prompt is better across that data set. So you're really comparing like apples to apples there. So that's kind of like the development phase. And then when you're in the testing phase, you can design some unit tests that are kind of inspired around that. It's not something I've done yet, but it's definitely something I see customers starting to do.
Yeah, I think you've covered almost all of it. So I can really start to see what are the analogies from a unit test to an integration test to an end-to-end test. And all of these have their counterparts in AI development as well. So I'm guessing teams that are in production and are improving accuracies are building all these three kind of tests and slightly different methodologies for all three today.
Cool. Other questions? Yeah.
one of the challenging part to do LLM in enterprise is LLM provider. For example, Google, Gemini, they deprecate the model every single year. By the time you finish all the wonderful embedding, vector database, pickle checks, you want Elasticsearch, you have to do it from scratch again. So it's never ending prototype. Are we going to get this thing in production for real? Because we depend so much on the cloud provider, what kind of preference they have, and profit margin they want to make on that day.
Yeah, I mean, I can take a stab at it. So I think I did talk about forward compatibility a little bit. So I think just saying that, okay, we have to be prepared for change and things are going to change is the only thing that we can actually do right now. Because things do get better. I haven't seen regressions happen too much. There might be blips when a model regresses a little bit, but then eventually it comes back up again as well. So I think building that resilience within your application, that it's able to consume newer APIs, newer methodologies fast enough, is, I think, the only way you can do this right now. A lot of enterprises I see are deferring production deployments because of the same fear that, hey, I do not know if this is going to be state of the art by the time we ship it to production, which is going to be maybe 4 months from now. So should we even take this up? But I think now that there's enough proof of ROI with GenAI in various different industries, it's just about setting up the right systems that enable you to be forward compatible as well. That's sort of my take on it.
Yeah, I think that's a hard question. I don't have too much more to add there, but I think probably the unit testing comes into play there as well. Like if the model is kind of changing under your feet, you got to upgrade to a new version. You probably need a set of tests that represent what you need the system to do so that you can run that test easily.
Yeah, just one version of what Rohit's talking about maybe is like in all the systems I've built, either off the shelf, something like LlamaIndex or LangChain, or just my own Python wrapper kind of thing, like a pluggable model interface is super relevant, or LLM interface. And so it's like LLM implements a thing called answer or get a structured answer or a few things like that. And then it's just like, well, let's try out Perplexity or Claude or OpenAI, and oh, OpenAI just released 4.0 mini, something like that. Like, let's just make a PR that changes like default model name to this, and then like see what our test suite looks like, and things like that. And yeah, I don't know why you mentioned Gemini. I didn't see anyone raise their hand on that, but like it's worth a try, I suppose.
Has anyone used Gemini recently? Has anyone used Gemini recently? A couple of you? Oh, there's quite a few people who've used it. Okay.
There you go.
You had a question?
Thank you. Hi, great talk today. Just a quick question. So I help customers with building systems like what you're talking about. All the time what I hear from them is about the cost. Like how could we give a projection on the cost? Like how much is it going to cost either to build, when you're building it, when people are using it, how would you actually put a limiter on it? What is your take on that? Like, since you have established organizations with monitoring, which also tracks cost, it's a bit confusing. It's more, how do you get that trust to customers when you project some numbers? Or what metrics would you consider when you're giving such things? That would be good to know some comments from you all. Yeah.
Super interesting. Yeah, like I built this super crazy thing, or we're proud of with that whole documentation reader thing before, and my finance guy's like, so you built a tool that when they hover over this, it costs us 4 cents, is what you're telling me? I was like, yeah, sorry. I guess I did do that. Or every time we log a embedding, it's like $9. I have actually talked to people that like have fine-tuned a local Mistral model and like got their costs way down and things like that. But I think at the beginning, understanding you guys remember like in like college or maybe high school or something, whatever, probably elementary school these days, like there's like big O notation, like there's certain number of things, like number of loops to retry something, or like number of steps in some workflow and timeouts and all these kinds of things to like keep a good handle on the things that like can exponentially get kind of out of control, and like know where to clamp down on these edge cases that can cycle around. And so like if it doesn't work, try again, and like up to n equals what, right? And like each time it like you can get in these cases that'll spiral. And so like at the very early parts of building, I would just like keep a strong hold on that, and also do that thing I said with the models, with the one model behind state of the art. Like 3.5 Turbo's doing okay on plenty of things these days, especially if you have a multi-step agent, and like one of them's just kind of like classifying a little piece of it or something. Like you can tune those things, and so keep those, know where those levers are, and keep them tunable, and maybe even on like a thing you can change in real time if you're at the end of the month or something like that.
Sorry. Thank you for the answer. But what I am grasping from what you just mentioned is these are all precautionary measures when we are designing, architecting, how having a controller which is a powerful model, and you have some basic models behind the scenes where you have your controller and you minimize the dots before you actually land up into an answer, which are precautionary things, which I don't disagree. But when I speak with customers, they don't like that all that. I mean, these are all technical stuff, which we understand. But in general, when we say insurance is a very good example, even banking, actually, I have few customers who are into banking as well. When we say ROI, when somebody invests to an employee, a chatbot dedicated to them, which is going to give them efficiency, how do we actually calculate this cost that is going to actually bring value to the organization? There are efficient ways, which I don't disagree, but is there any other thing other than those words that you just described that usually we, or in your own area, have used when you're speaking with customers?
Sure. Yeah, I mean, on every LLM call, you can actually get the costs, right? And so like I've seen the logging, and maybe your guys' platforms do that, like can actually say how much this cost you. In the end, if you're putting it up that against human time, like it usually wins. I don't know. It might be just a selling the vision thing. I don't know. If you want the magic, you got to pay the magician. I guess that's my advice.
Yeah, I think every ROI calculation is different because it's got to be specific to the use case. Sometimes you're going to be automating some task that nobody wants to do. Now you're saving time. So this is like a time saving. How much did it cost that engineer an hour to do that? And you've got to do that ROI calculation. If your system is like driving purchases on a retail website, now you've got like click rate, which leads to revenue for the company. So there's these very kind of specialized ROI calculations. In my experience, not always like the engineers and data scientists like myself are good at these calculations. They need to be paired with a business mind to help them kind of translate the model's value into the business value. And then you got to compare that to the cost of your system, which, as he's saying, is very measurable. We can get that. What I think we'll probably see as we start getting really good at doing that is that some of these are not worth the money. Some of them are amazingly worth the money. And I think we're in a very experimental phase where we just got to try stuff out. But yeah, hopefully that helps.
I think just to add to that, I think the cost of running the model is actually going down drastically month over month. Somebody did the math on this, saying if I talk to GPT-4o Mini 24 hours a day for 30 days a month, I would have spent $4. So it's actually the cost of API calls is like significantly dropping continuously. So I think it's not something that teams need to worry about and not experiment. But I think managing costs and improving costs. So I've actually we wrote a very detailed blog post on this, breaking out the Frugal GPT paper by the Databricks founders. And we wrote a blog post on implementing Frugal GPT. So if you just say Frugal GPT portkey, you'll get like a very detailed blog on here are 9 things you can do to significantly decrease costs, like up to 90%. But that's more an optimization you do after the fact. When you have your application running, it's returning ROIs when you start to improve on costs. I wouldn't recommend like going through that blog post or implementing any of that before you have your application running and it has a clear ROI there.
Okay, we've got under a minute left in our 45 minutes, so I'm going to turn off the alarm, and I want all of you to kind of give a one-sentence summary of what we should take away as the most important parts of AI in production.
I don't know, don't log embeddings.
If you do log embeddings, you can sample them before you log them. But I would say overall, the last thing I want to leave people with is don't be afraid to experiment. AI is growing really quickly. There's a lot of new tools all the time coming out. The best way to stay on top of stuff is to try it hands-on, and don't get disappointed if you built something awesome that becomes irrelevant the next day, or you built something awesome and then there's a new technology you should have used instead, things like that. That's just going to be the natural state of this industry right now. We've all just got to tinker with it and kind of grow with the industry.
If you're building something, we talked to hundreds of people that have been building things, and like they're not quite getting the answers they want out of this. Most people are like, oh, we need smarter models. We found that through working with people and their own experiences that like it's usually the data inputs into those models that need the work. Like you were hoping to throw it at this crazy PDF and it would just come up with the answers, but it didn't. So maybe like let's summarize some chapters and like put some metadata on each of those chunks and blah 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 blah. And next thing you know, like, oh wow, this thing is really great, and I don't even need a smart model. It's so it's not only about the magic robots; it's the grease that makes the data run. I don't know, metaphors. That's all. Thank you.
All right, thank you guys very much. All right, if you want to ask them individual questions later, they will be available. Now I'm going to ask you guys to get off the stage. And we're going to bring up our next set of speakers, our panelists. So we'll have Chan Lee, Daniele Bernardi, and Anishrut Gupta. Just because you got off the stage doesn't mean you should leave. We're going to take a selfie later. I don't know where everyone went, but make sure that you get ready for that. All right, so hey, you guys are the AI agents people. You guys are the hottest people in SF right now. I'm gonna put on this timer, and we're gonna get into it. So, who has the mic? Where'd the mic go? You have the mic. Okay, then you're gonna start. So. Tell us your name and what your company is building, and then we'll go from there.
Hey folks, I'm Anushrut. I'm the product lead for this new product called PromptQL. I work at the company called Hasura. We are a Series C company, 150 folks. We've been building a developer tool for data aggregation and data retrieval for a while. So instant GraphQL and REST APIs on your data sources. For the last 1 year, our AI lab has been experimenting with a new approach to building AI agents and a new approach of connecting your LLMs to your data. So instead of the traditional RAG pipelines, instead of the traditional function calling pipelines, text to SQL, multi-agent, we're thinking, what is the best way to connect any kind of data source? Be it structured databases, SQL, NoSQL, vector DBs, SaaS applications, APIs to your LLMs under a unified data query paradigm with a unified semantic schema. Under a unified semantic schema, how do you do complex computation analysis across data sources? How do you do fine-grained authorization and access control? How do you also run complicated queries where you don't have to pull a trillion rows of data into your LLM's context and ask it to answer a question? So that's what these are the problems we're trying to solve. So PromptQL is basically an agent that allows you to build these powerful AI applications and agents across any kind of data source, across all types of data sources.
Hello, everyone. My name is Chan Lee. I'm the co-founder of DBOS. It spells as DBOS. So it's based on my PhD research is actually a research project, a collaboration between Stanford and MIT for the past 4 years. So after I graduated last year, so we co-founded the DBOS company. So we are a serverless platform for building reliable backends. So we provide lightweight durable execution on the cloud. And so the funny thing is, we just announced our Supabase integration today. And if you are a Hacker News user, you will find us on the front page right now. So the Supabase CEO wrote, thank you, everyone. So basically, Supabase CEO Paul wrote a really nice blog post explaining how DBOS works. So please read it and please give it a try. And anything else I need to talk about? Oh, what? Oh yeah, so basically we provide durable execution, and we this year we found that it's a perfect fit for building reliable and production-ready AI agents. And actually I have a demo for that, but we'll talk more in the panel. And I think the missing part in AI agents right now is durable execution. So
You managed to sneak the production thing into there as well. Nice.
yeah.
Daniele.
Hi everyone, Daniele, founder and CEO of Toolhouse. What's Toolhouse? Toolhouse, it's a platform for function calling. Imagine everybody familiar with function calling? Wow, all right, so that makes my life easier. So we connect basically AI to the real world, but our infrastructure basically has all the code, all the prompts, and all the hardware that's optimized to run connectors between the AI and whatever you have, either an internal microservice or the usual like stock or weather API. You don't have to build it. All you have to do is basically go on and build a nice, fantastic user interface, and we take care of all the rest. So we're basically the platform upon which you can provision yourself a MongoDB or a Pinecone without you needing to configure and figure out what's the embedding model. So we aim to make the hard decision simple as just like installing those components in a dashboard, and you're good to go. That's the dream I had when I was 8, and now it's coming to life. So I love it.
Awesome. Quick question, a quick survey from the audience. Who here has built an AI agent? Okay, not a lot of people. Great. So this is actually perfect to start with you. How do you define an AI agent?
How do you define?
What is an AI agent to you?
Yeah.
This is something that's been talked a lot about online. It gets talked a lot about here in SF, but sometimes people think of it differently.
This is a hit question every time we have a workshop or an event, because people start to lose attention the first 15 seconds you pronounce that, like you say that word, agent, because people build it, but they don't know what exactly is. They just like trust the technology. So what is an actual agent? What's inside? It's basically an LLM, obviously, with a prompt and some tools. And the tools are maybe some APIs and some memory. That's it. That's an agent. The prompt is the agent, and the agent is tasked to do a specific task very well and provide like an action plan with bullet points. Each bullet points may resort to nothing, so thinking, reasoning, or a tool being called, or a memory. So that's basically an agent in a nutshell. Very, very simple.
Do you guys want to comment on this?
Well, I think AI agent, like my understanding is that AI agent is a program that is essentially an AI-driven workflow. Basically, it's not a predefined workflow. It's not a static DAG. It's basically driven by the DAG, or the execution flow is driven by the AI. Like if you are familiar with OpenAI Swarm or other like AI orchestration frameworks, basically you give a prompt to the AI, and the AI would give a bunch of tools, and then AI will decide where to go next. So it's like a decision tree, or you can call it a call graph, is driven by AI. So that's my understanding.
Yeah, I just add one thing to it, which is saying, like, instead of a decision tree, I would say more like a non-deterministic reasoning agent. Decision tree seems deterministic to me, but it's pretty much exactly what you said. So an AI agent is something which is connected to a bunch of tools. It's an LLM with a prompt given to it, and given a user input, reasons on its own, does a function call if it needs to, comes back with a response. That's it.
So, Anushree, you describe PromptQL as an agent, which means that you are one of the very rare people who has some experience with putting agents into production. Can you tell us a little bit about what's challenging about that? Any surprises that came along the way?
Yeah, for sure. So one of the biggest problems we faced with agents is the fact that you have to orchestrate them. And when you orchestrate agents, right, you have to transfer a bunch of context between agents. And at the end of the day, it's a language model that's doing all this orchestration. What if I want to transfer 100,000 rows of data? Do I have a memory management agent separately implemented? What if I want to transfer unstructured data? Let's say I'm looking at customer support tickets and I need to transfer, one is a data retrieval agent which gives me, let's say, my last 7 weeks customer support tickets. Another agent which specifically does, let's say, churn risk analysis. How do I transfer all of these tickets to that agent, right? All of that has to go through the LLM's context. That's where you start seeing hallucinations. That's where you start seeing context loss. And that's the problem which we really wanted to solve, which is how do you work on bulk data? Because enterprises have a lot of data. And how do you orchestrate these agents and how do you handle data movement between these agents without losing anything in them? How do you add determinism to that? That's one of the biggest challenges we have been trying to solve.
Yeah, that's actually a perfect segue into what you guys are doing, since you've also put an agents into production, and you were just commenting on how the durability is very important to agents.
Yeah, so I think the biggest challenge, so for now, most of the agents are just demos. And then I'm talking to people who are building agents into production. So basically, the missing piece is that agents are going to do many stuff on behalf of us. So I think there are a bunch of challenges. First is error handling. It's not like you're doing a human sitting there to monitor what's going on, like the customer service. It's going to be fully automated by agents. So you have to handle all the corner cases, all the failure scenario. Maybe a third-party API is temporarily unavailable. You have to configure timeouts. You have to configure retries. And then your LLMs may hit the rate limit, and you have to handle that as well. You may hit some concurrency limits. There are a lot of errors. And second, your servers may crash, because the agentic workflow may last for a couple of days. For example, the customer service agent may need to wait for some user input, and that wait will last for a week, for example. And then what if your service crash, or if you have some server upgrades, then you'll lose your context, and when you come back, usually do start from the beginning. If you start from the beginning, you may have duplicated entries in your data, or if you lose your data, then you have unfinished tasks, unhappy customers, stuff like that. So I think, to me, the challenge is that the AI, the LLMs look in very unstable, non-deterministic API endpoint. So we have to deal with that.
Daniel?
So our platform is a little bit more all-encompassing. We're not just enterprise. Actually, we're not enterprise. We're more for the rest of us. And so we see a ton of use cases deployed, and some are super fun, random pet facts or random cat fact. Every day you get an email with random cat fact. To some utility with agents that run for 10 minutes, and all they do is there's one agent that gets your it's called Gift Genie, by the way. They won a hackathon a few months ago, and they built this on top of Toolhouse, and now they want to deploy it for the holidays, obviously. So what Gift Genie does is this ability to go on a Twitter feed of a person you know and you want to gift with something, and post the tweets, see what kind of person this person is, and then debates with over 3 agents on pros and cons of some gifts. And then there's another agent that gets all these results and then go fetch links for you to e-commerces to purchase those things if you're interested. And obviously they want to make money of affiliate links on this, which is like a fantastic idea. But that, like to your case, like those agents can run for like an hour. And so that the problem with agents is that like you need to let them reason, and you shouldn't really fight the urge of, your developer in you wants to have like the conditional if then else. It's actually not like that. It's like more let them reason, let them figure that out. It might take hours. You just need to trust the process.
Very cool. Who's buying gifts right now? Oh, wow. Quite a few guys just not doing holiday gifts, huh? Okay. Oh, you're done. You're done buying gifts. Wow, you're done early. Okay, I haven't started yet, so. All right. I was going to ask about use cases, and you just gave us one. Do you want to give us another one, or you have another interesting? I mean, you have a bunch of interesting use cases coming up, don't you, actually?
So we just announced this thing called adventai.dev, which is going to gift you with one use case every day. So behind the idea of Toolhouse, I have to take a little digression to let you know about the idea. Like, why we did this? We did this because the first question I get asked by software development agencies, enterprise, like everybody wants to build agents. But then the second question they ask you is, okay, but what exactly can I build with it? I was like, come on, like everything, literally everything. So, but the problem is that you heard it from the other panel. Even for the founders, even for the CEOs, so who's making the technology finds the technology so hard to build. And it doesn't have to be like that. Like the number of times, like anybody uses Vercel here. I love Vercel. However, npm run dev that then calls next dev that then calls pm inside isn't a little bit too much. So those are the small things that then gets in the way. And if you want to deploy your Vercel app on Cloudflare, no. So that's the kind of complexity we've become to. And in AI, that's already built in. So you need to make all this kind of decision, you need to understand all these technologies, and then you don't have time left to actually build the use case. So we want to revert that, and that's why we built this adventai.dev. So every single day, you're going to have a little gift from us, which is a complete use case that you can first try, then if you like it, you clone it, and then you monetize. And if AI is delivering on its promise of democratizing development, then there are really opportunities for people to make their first like $1,000 a month on the side with just a few lines of code, actually with prompts. You deploy the app, you put a Stripe link, that's it, and you have your personalized Spotify playlist every day, so you don't listen to the same music all over again. So those are the small things that we're going to commoditize with AI, but nobody can build it because there's so much technology and it's all scattered, and you have to figure that out. And so with AdventAI, what we want to do is to just give you these little nuggets that you can just like play with and then make yours. And every single day you'll have one single app that does something, and it has the blueprint for you to figure out. So I just teased a couple already, but if you subscribe, there's an email button. So when it's out, you're going to receive your daily drop for 12 days, and it's all free, obviously.
12-day Advent. It's like the 12 days of Christmas, but like the Advent calendar.
Yeah, I think there are huge opportunities for building AI agents, but we don't have enough production use cases right now, but we see some of our users are trying to build it. We're talking to them. So like, for example, one use case is like, obvious use case is customer service. I'm actually going to demo one. So like, it's an actual use case. Basically, a startup is going to build that. Something like personal AI assistant, you upload a receipt, then help you reimburse, analyze the PDF, extract information, and do a bunch of things to fill out the form, and then update your database, and then submit the form for you. So basically, I think it's basically AI agents will automate a lot of manual process in the future. And I'm talking to people who use AI for law, like for example, underwrite. I think it was also mentioned in the last panel, so a lot of things could be automated with AI. And then I think all those things could be defined as AI agents. Yeah.
So we have been trying to put together this benchmark called the business data benchmark, which is basically a set of real world user queries on real world data domains. So we saw a few use case sets, such as the most common we saw were email and calendar management. Second was customer support. Third we saw was engineering management. Fourth we saw was human resources, HR. And the fifth I'm forgetting. But so these were the different domains we saw where people are trying to build the most number of these agents and assistants, mix of those. But one thing we noticed is, like keeping the customer success example right now, we noticed that you can't answer a question like this. For example, if I open up an assistant and I ask a question like, what were the customer support tickets created in the last 7 days by my enterprise customers, which are about, let's say, service timeouts, and the SLA was not met. Can you also look at the interaction between my customer support agent and the customer in those specific filtered tickets? And tell me if they have been satisfactorily resolved or not. And if they have not been resolved, can you issue $100 in credits to this customer? Now, this is a realistic user query on a realistic business domain, which has been asked by one of our customer success people. Now, what do? Do I create agents for each and every single step of this process? So I need to know what exact questions my customer success agent is going to ask, right? One is like a tickets retrieval agent. One is specifically like, is it about service timeouts or not? So that like a classification agent which can look at tickets and identify what's happening there. One would be an agent which specifically does, let's say, analysis of the entire thread and tells you whether it was satisfactorily resolved or not. One will be an agent to issue credits or something like that. Like, or that'll just be a tool, not an agent, but still. So do I implement all of these and then create this one orchestration agent which has clear instructions when you see this user query, figure out what needs to be done? Now, how many of such agents will I end up creating, right? Because my customer success rep can ask whatever they want to the assistant. They have so many different types of tasks that they need to accomplish. How do we achieve that? So these are the kind of challenges that we need to be solving. That how can we basically spin up agents on the fly? How can we create these logics on the fly, which can deterministically be executed by like one single agent?
Okay, so I think this actually brings up something interesting that I've also seen around. I don't know if you guys, who's heard of human in the loop? A few of you guys, most of you guys have heard of this human in the loop thing. So everything that you guys have been talking about today have been about fully autonomous agents. So what about human in the loop? Have you tried using that? Is that something that you would consider trying? Is that something that you think maybe it's going to be, something that we're going to use for the next year or so, but then it's going to go away as agents get better? Like, what are your thoughts on that?
Yeah, so we do have human in the loop in our agentic process, but only for like right operations. In the sense that when I in this query which I just shared, right, the final step, which is issue $100 in credits, right? That's where I want to flag this to the user that, hey, to the person who's prompting it that, hey, I'm about to issue the credits. Because I want determinism in that step. I want to first see your entire chain of thought, your reasoning, your logic behind all of this, before I can approve that $100 in credits, right? And I want this detection of a mutation, right? Which is that I want to make sure when an agent is called, which is about to make a mutation, make a database write quick call or like a post API call, I want to make sure it's deterministically flagged because I don't want to miss out on any execution where it just happened without the human in the loop. So that's something, again, a problem that we are trying to solve, where the human needs to be involved, or at least let me build the capability where 100% deterministically I should be able to flag when an agent is about to make a permanent change. So yes, so we are seeing a bunch of these human in the loop kind of things, and that will always exist until we are so sure, like until we are so sure that AI is sentient and as good as a human operates. So
Chen?
Yeah, actually, that's a great question because I'm going to demonstrating how I implemented human in the loop with DBoss today. Yeah, so I think human in the loop is definitely very important because even though we expect AI to be autonomous most of the time, but for critical decisions, as you mentioned, we have to have human to verify. Like if I want to issue some very critical refund, for example, I want like admin to verify it and approve it. If I have some like if the AI says I couldn't decide it whether I should do this or not, then we need human in the loop to decide the next step. And then for human in the loop, I think the challenge is how to guarantee the execution runs to completion. So I actually look online, like how do you do this with LangGraph with existing AI frameworks? You have to manually snapshot your execution state, pause it, wait for human input, and then restore your last step, and then continue. So that's one thing that DBoss is really good at. Basically, we persist the result of every execution, and then we provide primitives to help you wait for, say, a few days or a few weeks. And then you can continue from where you left off when you receive the input from user or timeout. So yeah, I think human in the loop is definitely important, but it's kind of hard to implement it correctly.
100%. 100% on the fact that current frameworks don't handle it well at all. That's so terrible. I won't drop names, but it's terrible. But anyway, yeah, human in the loop also reminds me of that scene from Modern Times where Charlie Chaplin gets like gobbled by the machine. But it's an artifact of the times we're living in. Like the technology is so immature, and we need that. To me, it's more of a philosophical question because like we are agnostic because we provide like function coding, so we give the LLM the tools it needs. Then it's up to the workflow you prepare with the language you prepare and the framework you prepare to figure out what exactly and when the human should be involved or not. So for us, we have the luxury to approach human in the loop from more like philosophical perspective, where like aren't we when we chat to ChatGPT already in the loop, you know? And should it be the opposite, where like we should try and model our agents in a way that are more self-contained and maybe performing smaller tasks, and then having them telling us when they need help, as opposed to us reviewing the result every single time, just like you were mentioning before. And then lastly, like another interesting aspect of human in the loop is sometimes conflated with evaluation. How do I know that this system that's supposed to make my team 4 times faster is producing as accurate results as my team? And that's actually a question that I received once before I started my startup. I was freelancing as a prompt engineer. And then I asked the guy, like, how do you evaluate the work of your team? And they say, I don't know. So that is the quintessential questions. Like if you scratch below the surface, you'll find that there's a lot more than meets the eye. And most of this kind of drawbacks or pushbacks can be easily confuted with making sure that you have an initial benchmark to begin with.
All right. We're at just a little bit under 20 minutes, so I've got a couple more questions for you guys, and then we'll open it up to the audience. So this is probably going to be a somewhat long question. Chin, I feel like I probably know what your answer to this question is going to be. I don't know about you guys. So one of the challenges with AI agents is because they're LLMs that are making calls, and LLMs are these stochastic machines that are going to be making mistakes percentage of the time. Over time, if you let the agent run and you have a lot of steps, your error rate compounds. How do you handle that?
It's a broad question. I'm going to hack this question and tell you that used to be a problem like maybe a year-ish ago. Now the LLMs are getting better. Like I've told people loved Sonnet. Sonnet is one of the most like, I wouldn't say deterministic, but you can expect results even at like a very high temperature. You don't have to set temperature down to 0.1 to get always these like similar results. So it's true that that is going to still going to be a problem, especially when you go and feed a ton of data into the context. But there are actions to mitigate that. Like the problem is to implement them, obviously. And we hope that tool house is going to make like life easier. Like you install the semantic memory tool, and all of a sudden you can just like have context handle over, and you have memory management that all the LLMs can access, whatever LLM you have. So those things are like getting better, A, because the models are improving, and two, because you have a ton more accessible technology today that makes the problem still an okay problem to solve, but a little bit less relevant than it was like 2 years ago or last year as well.
Jen?
Yeah, so I think this problem has at least two aspects. So first, you have to be aware that failures do happen, errors do happen. There will always be bugs, and with LLMs, the bugs could be harder to handle. But you have to make sure that your programs handle those errors in the runtime. Like it shouldn't just crash itself when it receive like a 502 or some kind of errors from your third-party calls. So like that's where like we need some automatic retries, some error handling logic. And that's one thing that dboss is trying to do, is that you can configure how many times you want to retry, like exponential time back off and all the things. And second, the thing is like failures do happen, so we need a good logging, tracing, and debugging system so that if something goes wrong, like for example, engineers will be able to debug it by looking at the logs, querying the logs, and see what's going on and fix it. I think it's unavoidable to have someone to manually fix it, and actually that's a common case for existing systems. When we talk to people, like they say, well, yeah, it does fail, but when it fails, we'll look at the logs and fix it manually. So we can improve this by providing better error handling and then providing more robust logging, as long as you don't log embeddings, I guess.
Anushree?
So one approach that we have taken is taking agent orchestration away from the LLM's context itself and doing agent orchestration in a programmatic runtime. So basically asking this one orchestration agent that, hey, why don't you write code? And in your code, do two things. One is, and also another thing which we have done is abstract away your data retrieval pipelines. So instead of having different agents with different data retrieval pipelines, your RAG pipelines, your text-to-SQL pipelines, your function calls, these kinds of things, abstract everything away into a single unified data access layer. So now this single unified data access layer is what your LLM will call. It will express its data requirements to this single unified data access layer. And that data access layer will deterministically fetch the data from whatever underlying data source you might have and give it back to the LLM. And all of it, this first orchestrated LLM is doing it in a programmatic runtime. So in a programmatic runtime, it will write its data retrieval query. It'll say execute. It'll hit the unified data access layer. It'll pick whatever data is needed. If it needs to do semantic search, it'll do that. If it needs to hit an API, it'll do that. If it needs to write a SQL query, it'll do that. It'll come back. And now, because it's still in its programmatic runtime, you assume like it's in a Python code. So now I can do whatever follow-up I need to do that in my programmatic runtime. One another thing which we have done is added this concept of a structured memory artifact, like structured memory to the LLM. So as Daniel mentioned, right, this unstructured memory management kind of tool that you might have. Having also a structured memory kind of thing baked into the LLM's runtime. So which is, you have the LLM context, which can handle unstructured information. Let's also have a structured memory for the LLM, which it can tap into in its programmatic runtime. So let's say, find me the top 100 users based on XYZ characteristics. It'll get you the top 100 users, but it'll save it in its structured memory. Now, if I ask a follow-up question, okay, which of these customers has at least 2 support tickets? Okay, I'll demo this thing in a few minutes. Now, it doesn't have to remember any of these customer IDs or the customer names or things like that. It can just in its programmatic runtime say, okay, pick my last artifact, and then based on this artifact, run a loop and filter it down for 2 tickets. So this kind of a thing just helps solve this problem a lot better.
Cool. We'll go very quickly. You guys all know what Pokemon is, right? You guys all know what Pokemon is, yes? Yeah. You do not look like you know what Pokemon is. You know what Pokemon is?
Well, I do, but I only watched it.
All right, that's all you need to know for this question. If you're a Pokemon, which one would you be?
I'll be the Charmander, the first generation. Yeah.
Pikachu.
Okay.
I wish I could be a Snorlax because I'm so sleep deprived the whole time.
All right. Flavor of ice cream, which one would you be?
Ooh, hazelnuts. But it has to be gelato, Italian representing.
Wow, okay. Chen.
Ginger, it actually tastes pretty good.
I don't know why we don't get this in the US that much, but butterscotch. So butterscotch ice cream. But my favorite gelato is pistachio.
Okay, very cool. So now we'll go back to actual questions. So audience, questions.
Hey, I'm curious about if LLM become really good at writing codes, then isn't it LLM will be able to generate tools in the future? So that's for Daniel. And the other question is, as a founder, like I'm curious about how do you guys monetize your tool? Because one thing is people using it, another thing is people paying for it.
Uh-huh.
So I'm curious about that.
If you want to take a stab at this, go right ahead. So 2 things. The first was on if LLMs become good at coding, can they code their own tools? They are good at coding, actually, and we don't mind. So fun hack, we have a code interpreter sandbox. It's not E2B. Everybody knows what E2B is. Some do. So great panel. So E2B is a sandbox as a service. So the LLM or you can just like throw some code and they'll do their magic and give you the result back. It's great, but it's kind of limited. So we built our own E2B, and it has an agent behind the scenes actually that gets the code, make sure that you're not downloading like porn or nasty things, and then it creates a virtual app and install whatever library you need, like whatever. So pip install, poetry add, whatever it's in your code, we do it, and it just runs. So if you can fit whatever code you can in half a gigabyte of RAM, and you can run within 60 seconds, you can do whatever you want. So the hack is you can install Code Interpreter and then ask the AI to write code to do something like an API request, look into your inbox, like whatever you need, it does it. And it's great because it has saved us a ton of time not writing tools, and a ton of users are using it to that extent to call public APIs or to do like more better scraper using sources that they have and we don't necessarily provide or want to provide. On that other side, pricing, we price users every time the LLM decides to use one of these functions. So it's up to the LLM to charge you, basically, but it's predictable. So you can actually tell the LLM, hey, limit your executions to 1 per call, or don't call tools on this turn. So there are so many things you can do. But usually we see that it's like people spend very low, and that's totally fine because we're like we're not thinking about revenue right now because we want to figure out how many people believe in this mission. Like, how can we help like hundreds of thousands of developers building their own stuff and making like the small defensible projects out of it that can get to like their own 1,000 users, so they can monetize like 5K a month. So that's our goal. Then at that point, we'll start introducing like the pro plan, the ultimate plan, the enterprise plan. Doesn't matter right now.
Yeah, so I think the AI sandbox is actually a very interesting new thing to me as well. Like I was just talking about it with someone a few days ago. So E2B is obviously very interesting, and basically you can put your the AI generated code in this very secure micro VM like Firecracker, and then you execute the code in the very controlled environment without destroying your outer agent. So in my opinion, that could be just a step in the DBoss workflow. Like you just isolate that step to execute in the sandbox. And then you record the output, record the input so that you'll be able to reproduce it when you, like, for example, do a failure recovery. And then on the second question, so we provide open source library to help you build those tools, help you build like reliable workflows and agents. And we charge you if you want to host your applications on the cloud. So we have a serverless platform. You can think of it as AWS Lambda or Cell functions. So like that's basically we guarantee that we automatically scale it up and down to handle your traffic. And we guarantee that if your service crashes, we can automatically bring it back and make sure your workflows always run to completion. So basically, we charge for hosting services. Yeah.
So I love this question because it's at the heart of exactly what we're doing, which is we wanted to emulate a human being, like an analyst, how they would answer a question. So it's like our agents are basically human analysts, but machines. So when you ask a user a question, right, what do? They first think, okay, you have asked me this question. This is all the data available to me. This is a plan of action that I should take. Now I'll spin up my Jupyter notebook. I'll start writing some code which will fetch data, process data, compose data, whatever kind of things I need to do, and then come back with a response, right? Like that's how a human would do it. So we said, okay, why can't we make AI do the same thing? So when the user query comes in, look at the unified schema across all my data sources. Come up with a query plan. In this, then if the query plan seems right, go implement it, write code. So we also wrote our own code interpreter. We didn't use one out of the box because we wanted to just limit it to certain dialects of languages, these data retrieval languages. So best part about writing code is you can express a few things with it. You can express your code requirements. If let's say I write SQL, best part about SQL is a Turing complete language. So you can write any data requirements in SQL and then write a translator later which can translate SQL into a MongoDB call, SQL into an API call, SQL into whatever. But just let your LLM write SQL because they're great at writing SQL. Make your LLM write code because code is a way to define analytical requirements. Then make your LLM call another LLM if required for any semantic task. Don't bloat up your own context, right? If you need to analyze support tickets, don't pull the support tickets into your own context. Call another LLM, delegate the tasks to a downstream LLM. Now you can do all of this kind of orchestration, SQL, logic, and semantic tasks. Everything in just code. So I love this question, and it's exactly what we're doing, which is writing code for everything. Second question is monetization. So what is because our model is bring your LLM, bring your data. So the place where we monetize is the complexity of your underlying data sources. So when you connect your data sources to this unified data query layer, right? This, what we call it a supergraph, which is this unified semantic metadata layer. The complexity of that metadata layer is what we charge you on. And it's a number of models in that. Model means like a table in a SQL or a collection in MongoDB. It's like a unique entity. And the number of active models. So if a model has been queried at least 1,000 times in a month, that's an active model. So number of active models you have with us, we will charge you based on that.
Sounds like everybody's using agents to write code. All right, audience questions. Audience questions. I'm gonna go back to here.
Hey, thank you. So this question is more about this. So agent has been there for some times, and there are all kinds of frameworks from the old ones like Longchain, the new ones like Swarm. What's your guys' take on frameworks? Some guys said they love it, some guys they hate it, just want to start from scratch. So I want to know, what's your guys' take?
So I'll quickly answer this question. So we did not use any framework for our product. We wrote everything from scratch because it just allowed us a lot more flexibility. And because we approached this from a more first principles point of view, where things have not been defined. Like let's assume RAG did not exist. Let's assume function calling did not exist. Let's assume semantic search did not exist. First principles, language models exist, data exists, and APIs exist. How will you create a system which can interact, which can allow your LLMs to interact with any data, any API? So we did not rely on any framework. We built everything from scratch. which just allowed us a lot more flexibility in the kind of first principles way we were thinking. I'm curious to hear your thoughts.
Yeah, in my opinion, all the frameworks are wonderful. Like they basically you pick one that is the easiest one you can use. I think for DBoss, our goal is to be able to kind of bolt on durable execution, the kind of persistence layer on top of any AI framework. So you can use DBoss to build reliable tools and then to be used by your existing AI agents. Or you can also build AI agents from scratch using DBoss. So like it's very flexible. I don't think there's any kind of right or wrong. It's mostly about your developer experience and user preferences. And use tools whenever possible. And if you cannot fit your problem to use specific tools to fix it, then probably you need to consider switching tools or building something from scratch. Yeah.
Plus one, we like as Toolhouse, our stance is to love all frameworks and to go where users are. Like we don't particularly build our agents just like you on any particular framework. We go bare like completion calls and try to stay as close as the prompt as possible. So that said, our opinion I don't think matters much. What matters a ton is what users really think of the incumbents. And you probably start to see a couple of things. Like those frameworks used to be very good and very well adopted 2 years ago. And now what happens? Like they all raised money and they're all like enterprise. And what happened to their community? They ditched the community. There are two things happening there. Like I said before, models have caught up. So most of the things that those frameworks are doing is no longer required for like 80% of the use cases. And some developers have backed up of those frameworks and they went back to things like agentic frameworks or routers, LLM routers most of the time. I have a counter that keeps track of the days I go without hearing of somebody backing out their implementations. It's like I go to an event like this and we start talking about, I don't know, name one, LangChain, and they say, oh, I actually don't like LangChain anymore, it's so nebulous, and I realize that it's making me spend so much money on tokens and function calls. I was like, yeah, I know. So those are the kind of the signs where that tells you that the ecosystem is already shifting towards something different, something new. Obviously, this one thing of agents is the new thing. I myself, like, I don't know if this is going to be the future, that maybe 2025, 2026, there's going to be another buzzword. Guaranteed, you know. But what we need to do as like technology makers is to support you as users where you go and to make those like difficult decisions as simple as possible. So if you want to back out of agents because I don't know, like what's going to be next, like AI kittens are going to come out and they're going to be smarter than an AI agent, then as many cats are. So we need to support you, and that's going to be our job.
Cool. So the timer just went off, but I'd like all of you to just leave us with one sentence real quick. What should be the takeaway from this panel?
Yeah, I'll repeat myself to death, but as Leonardo da Vinci used to say, simplicity is the ultimate sophistication. Think of that when you choose your next framework.
Yeah.
Jen?
My takeaway is that eventually we want to integrate AI and LLMs and agents into your actual software framework, and then to make it really production ready.
My takeaway is that code interpreters are what's going to put the brain in your language models. So make your language models more analytical, more intelligent, is determinism through code interpreters and reasoning through LLMs.
Cool. Thank you, guys. Let's take a quick 5-minute break before we do the demos. If you spoke on the last panel, please come up. We're going to all take a selfie together. Claire? Where's the other speakers? Teo, where's the other speakers? There he is. Brian, where's Rohit? Rohit, where are you? Rohit, are you here? Where's Rohit? Where's Rohit? He's on his way. All right. Ah, there he is. Claire, you want to come real quick?
This is the good mic, right? All right. Testing 1, 2, 3. Looks good? All right. Be sure to grab more pizza, everybody, because there's plenty left. Thank you. Should I bring on? Who's our first one? Rohit. You want to announce anything, or you're good? I just want to make sure he's set up.
I'm just gonna say like, oh, we're gonna do demos, but I'm just gonna grab people from the hallway and just be like, get in here.
That works. Perfect. Yeah, this work for you? We don't want you having to do like a whole holding microphone, so we're gonna try out and see if this works for you.
Yeah, this is perfect. Yes, thank you so much. I just hope that I'm not in the view.
Yeah, so we did double check over there. You can see actually how you look. Do you see that in the message?
Oh, okay, perfect. Yeah. So
it's not going to be the most clear on the screen for the people who are watching the live stream.
Mhm.
People here will be able to see. If you need, we can always move you a little bit more this way as well, if you would like.
I think this is good.
You want to try talking in here?
Yeah. Hello. Can you folks hear me?
I'm gonna put you on a 5-minute timer. I'm gonna do a quick announcement to everyone to just shut up and pay attention, and then I'm gonna put you on a 5-minute timer.
After I start.
No, right now. Hey everyone. You'll have time for networking in about 30 minutes or so. For now, I'm gonna ask everyone to shh. Okay, we've got our first demo as Rohit from Portkey.
Awesome. Thank you, guys. So I didn't actually want to show you all of Portkey today. You can go to portkey.ai and figure out what the product does. I'm going to show you something new that we were hacking last weekend. So I'm particularly excited about Model Context Protocol and how that allows you to connect some of your local services data to AI applications that you're using. And we were trying to see how could you use this protocol to actually make tool calls out to everything else. So this is Portkey. I mean, you can do a lot of stuff here, but I'm going to show you something that's really, I think, even before alpha. So happy to get feedback. It's a small setup. I feel it might be useful. So I think why I'm particularly excited about the Model Context Protocol is because you can actually start to build these nice little chat completion loops with added context built inside it. That's what is an agent, in common parlance, where you have the user input coming in. The MCP client is actually going to pick all of the tools that are registered in the MCP client, make the chat completion call to the LLM, and if the LLM suggests a tool call, we delegate it to an MCP server. So essentially, all of the tools and the execution of the tool is within the MCP server itself, which is crazy because you can actually run these MCP servers on your local machines, which give you access, to the right tools, et cetera, without authentication needed. The server is going to execute the tool, return the result, add it to a chat context, and then loop it over. So it's that easy to actually build a flow that can achieve some really cool results. And I'm going to show you one of the results that we achieved and we were geeking out over some time back. So we actually created this Cloudflare assistant of sorts. And while this is a toy, you can just look at what's the possibilities that are available with this. So what I said was, if you can look at this, I said, you're a Cloudflare developer. This is your objective. Write the code needed for this worker, deploy it to Cloudflare, and send me a Slack notification when you're done. Now, it's just like I've not connected any nodes. I've just done simple steps. And I have my MCP servers running in Portkey's AI gateway. So I have access to 88 servers that are available today. So it's still very, very early. It got announced like 10 days back. And I've just given it access to Cloudflare worker put. It can list my Slack channels. And then it can also post a message to Slack, right? So this is all that I've really done. And if you remember that graph I showed you, I'm just now going to loop these requests and try to make an agent out of it. And I really hope this works. Yeah, so this is a sample prompt. We could actually try it with different prompts as well. So I said I want to build a calculator app that renders HTML, allows addition, multiplication functions. That's it. So I have this string and the prompt I've written with MCP running in the background to give it all of these context and actions that are available, right? So I'm going to run this assistant. It's actually making this call to Portkey's AI gateway, and it's now making the call to LLMs and generating some data. Generating the code takes some time, so let's see if this really works. Perfect, so it's come back with some code. So it says, I'm writing this worker. Then it called this tool, which is CF worker put. Then it said, I'm going to list all my Slack channels. And this is all automatic, right? This is the LLM doing it itself. It received the result of the Slack channels list. Then it posted a message. And it said, here, your calculator app is ready. So all of this cool stuff that we're seeing on v0.dev, et cetera, can now be very easily built within your own niche applications. So this is actually said, I've deployed this to Cloudflare workers. So which is really cool. If I click this, this is actually the application that it deployed. I think it's an older application. Perfect, it did fail. Yeah, but the idea is that it was able to deploy a code base into Cloudflare. And I'm hoping this did send me a Slack notification as well, yeah. So on my Let's Learn channel, it said, the HelloWorld application has been deployed. So it actually went through multiple steps just using MCP, and then you were able to perform something. So toy right now, but lots of possibilities around what you could do with 88 different servers and hundreds of tools that are now available via the MCP protocol. So yeah, that's me. Thank you.
Very cool. I love how this highlights exactly what I was talking about with the agents. They're going to run into problems. Anyway, Claire.
Probably a little. Hey, everyone. All right, so we're talking about Comet. I know I've got about 5 minutes here, but I can do this. So what is Comet? So we are a platform that is used by enterprise and small companies alike for their machine learning workflows. Specifically, we are experiment tracking. So if you're iterating, if you're fine-tuning a model, things like that, you want to know what you did, be able to reproduce that. So we're the experiment tracking component. Also, if that model is going to run amazing and you love it and you want to move it into production, we also have a model registry. So you're going to be able to actually track what on earth is actually in production and make sure everything's looking great there. Then there's also production monitoring, which I talked a little bit on the panel. And then last of all, there's LLM observability. That's what I'm going to show you today. LLM observability is really going to give you that ability to get insight into your LLM app as you're building it. And what we released is completely open source. So even though we're working with a lot of enterprise companies and all of that, if you want to get tinkering with this right now, it's available. We got a GitHub repo that I'm going to show you. So let's jump in. I'm going to show you with an example project. I have a RAG chatbot, and this is one of those chat with your documentation, like simple use cases that y'all have probably seen over and over. But what we built is a chatbot that chats with the Comet documentation because that's a tool we needed, our customers needed. And we also used it to demo OPIC. So OPIC is our open source tool. It is really easy to integrate. I'm making sure you guys can see this pretty well. Yeah. So I'm going to show you the integration here. You can see my Python class, which is Comet bot. It's just that RAG chat bot. It's got like an LLM call and a retrieval step and all that. But what I really want to be able to do with OPIC is I want to track those different steps in the tool so I can get insights into the inputs and outputs of everything and evaluate the performance. And the way we do that with OPIC is really easy. You'll see with the code here, I'm importing OPIC, which is our open source repo from Comet. I'm importing a bunch of cool stuff like evaluate. That's how we're going to calculate a metric. We've got some pre-built metrics for hallucination and answer relevance, which is awesome. And then we've got something called track OpenAI. So what this is our built-in tracker. If you're building on OpenAI or any other kind of common framework, you're not going to have to do a lot of coding to integrate OPIC. We are already integrated for you. We know what the inputs and outputs of an LLM called OpenAI look like, and we know exactly what to log for you. So that integration is super easy. The way it looks in my code is like this. So I'm instantiating a client that is doing the logging through OPIC. And you see this cool little track decorator at each relevant step. And this is what's going to show up in the logging that I'm going to show next. So I'm tracking the step to retrieve documents in my RAG. I'm tracking the step where I get an answer, which is that call to the LLM. So there's multiple steps here. And I want to really control what's getting logged. And that's how this track decorator works in OPIC. Cool. Let's jump in and see OPIC. So this is what it looks like. You can kind of see it. How about that? So each row here is a call to my LLM chatbot. You can see great information that's useful to have, like the start time and end time. You have a unique ID for the task. But more importantly, you've got inputs and outputs, and you've got these hallucination and answer relevance metrics. So these are those metrics that you want to monitor, make sure this thing isn't going off the rails. It's also what you want to look at while you're developing, maybe iterating over prompts and things like that. When I click into one of these, you can see where I placed that track decorator in my Python code. I'm actually telling it to track these different steps. So each call has multiple kind of steps here. So this is what we call a trace, and within the trace, there's spans. And you can see these different spans. There's 3 here in this trace. So the trace is kind of a single traversing through that entire path in the system. Each step is a span. What I have here is that get answer function you saw. I've got that retriever step because this is a RAG, and an additional step there, it's putting everything together. What you can do here is you can see the inputs and outputs. So this is really a powerful debugging tool. It'll help you narrow down exactly what's coming in and out of these systems. If you feel like it's breaking, maybe at the retriever step, you would get insight into that. For a RAG system, it's really great to see what documents are actually getting retrieved. And you're even seeing like the query that was sent in that prompted this response. Some other stuff to look at is going to be the metadata around the model, and then finally the feedback score. So I want to go here. These are your LLM metrics. So I mentioned we have those out-of-the-box ones, but we also have a way to customize this. So if you want to track like hallucinations, it's going to be a binary output, 0, 1, hallucinating, not hallucinating. That's all built in. But you also have the ability to customize these, and we've got the full list of metrics here. So this is everything you would expect an LLM system to maybe need to be evaluated for. But if you have something beyond this list of metrics, the customization is really quite easy to do. It is a prompt, and we've got this kind of framework here. I really think of OPIC as like a framework for logging traces, a framework for customizing your own metrics. So this is what it's gonna look like here. You're really kind of defining your own logic for the metric, and then that will be automatically run. You can log it the same way I showed with the Python code, and it's gonna show up here with your traces. Cool.
Thank you very much, Claire. All I see is this big pink in my vision now. Okay, Chin from DBoss, where are you? Ah, there you are. I'll just give you the mic.
I probably need.
You're right.
Every time I do a live demo, I'll be extremely anxious because live demo often goes wrong. Yeah. Okay, hi everyone. So I'm going to share a few slides before jumping to demo. So hi, if you forget who I am, I'm Chen, the co-founder of DBoss. We're helping you to build reliable AI agents and tools that can be used by your agent. So as we just talked about, AI agents will be more complex. Like you will require human in the loop. You have to handle, your agent will probably handle your payment processing. It will send emails, it will send your Slack messages. It will do online shopping for you. So it's going to do a lot of things. And today, what I'm going to demonstrate is a refund agent. So it's a customer service agent. So say like, I want to refund something. It will first update a database record saying, it's pending refund, and then instead of directly processing it based on the price of your order, it might send to a human an email to say, verify this. And then given the human input, it decides whether to process the refund or reject the refund. And then, so based on the human input, if you process the refund, it may talk to other service, and then you have to update the database record to refund it. Or you can also reject the refund and say like, reject it. So this is a basic like AI workflow, like an agent workflow. So before jumping into the implementation, I want to say why it's so hard today. Like building reliable applications is really hard, not just for agents. You may get errors, failures, duplications, corrupted data, and everything. So it's really hard. And with agents, it's even harder because you often rely on the LLMs or rely on your agent workflows to self-fix those. And building reliable AI agents are even harder because most of, as we talk about, like we want those agents to be autonomous. And then like if everything is asynchronous, it's simple. You just block waiting. But often the time we want agents to process things probably asynchronously, like call out to Stripe and process something else and then wait for a callback from Stripe. So like because AI agents will be asynchronous, have a lot of real world interactions, like human in the loop, can take days, anything can fail. So you have to handle the failures, not just the machine failures, but also API failures. And also you have to handle async callbacks. So today, can you do all of this? Of course. So here's the AWS reference architecture if you want to build something that calls asynchronous external APIs. So you have lambdas, you have step functions, you have like a drop queue, you have to handle your asynchronous callbacks in very difficult, complicated ways. It's all doable. But it's a nightmare for ops, right? And some users even told us that with step functions, they gave up on code review. They just test in production. So how do we solve it with dbots? So we think we can implement durable execution as a library. So instead of asking you to write a DAG or like construct a workflow like a static diagram, we just ask you to write normal functions. So this is an actual code, like a slightly simplified code from our actual code base. Here's your refund approval workflow. You just say, send an email for a human verification, and then based on the human input, you decide whether to approve or deny it. You just write it, write Python or TypeScript functions, and then we use decorators. So you annotate your function, your code with a step or a workflow of steps. So we think this is the most natural way to program AI workflows. And then with that, you can just execute your code in any environment, in Lambda, in like our serverless cloud functions. And if anything crashes, we can always resume from the last completed step because we persist the outputs in the database. So we basically implement the memory into your function, into your program. And so dbots is just a library. You can integrate with your apps. You can use dbots to build your entire AI agent workflows, or you can integrate it. You can bolt on your favorite AI frameworks. And today we just announced the Supabase integration, so you can bring in your own database, your own data source for that as well. And I'm going to show you the demo. So I built this demo with dbot and Swarm, and we call it Durable Swarm. So I actually did a demo earlier last month. And then the source code is also on GitHub. So this is a slightly simplified version of the diagram I just showed. Basically, it's a chat interface. You say, I want to refund, and then it will update the database, and it will update whether, given the admin verification, will decide how to update it. So I'll quickly. Yes. So I say, I want to refund order 3. So yes. What is my refund status? It says pending refund. Okay, it's pending refund, and now I'm going to check my email. Oops, I got a new email. So the email sent from my agent. I'm going to click approve. So by the way, you notice that this approval workflow is completely asynchronous. I can continue chatting with my agent. And this is just a background process. We work. Now, what's my order status now? Since I approved. So now if you query it, it will look up the database and say it's refunded. So basically with dbots, you can build complex agents. You can process anything asynchronously in the background and also reliably. So thanks. Please give it a try and talk to us. And add me on LinkedIn. I also want 10,000 followers.
100,000. Next one. All right, thank you very much. Danielle, you're literally right there. Okay.
All right, you all. Would you like to learn or would you like to build?
Learn and build.
So So I don't have slides. I actually have nothing. So I only have use cases, and we're going to just like run one. I'll tell you what Toolhouse is. Let me just like set up my screen because I was running my own use cases on Toolhouse. I was like doing some inbox optimization. So Toolhouse looks like, when it appears, this. Here you go. It's almost like a store for like tools. So those tools are basically things that we tell your LLM, whatever LLM you decide to use, to adopt. So right now I installed a tool to get the content of a page, do web search, search X, get the latest news, even generate images. Maybe we can start from there. And then we have more. You pick and choose, just have fun. If you don't know what to use, you can actually ask the playground. And that's one of my favorite use cases when we go to hackathons or where we meet developers. We actually ask the LM can just look at what you have installed and tell me like some cool use cases. And so there's this button and just like tells you the roll of dice and you have like a use case. Oh, nice. Yeah, maybe we can try this one. Let me blow this up. And so because the LLM now has tools at its disposal and has creativity, it can even think of its own use case. So maybe, I don't know, we can try and get this use case a go, see what happens. So it might break, it might work, it might be awesome. We might all be crying. And by all, I mean myself. Oh, it's getting current news. Yeah, it's talking about conflicts. Yep. So behind the scenes, the playground, that's obviously just like a toy playground you can use to fine-tune your prompts before you finalize them and put them into your app. This is your news digest. So what do I have already installed here? Okay. With this, I have an idea. I have, I kind of want to create my own newsletter. Let's see if I can send myself an email from here. Nice. Now I'll have to reset. So I'll just copy the prompt. That's going to be my mini app. It's going to do something similar. And then at the end, I'm going to ask, can you compile news digest for this? Just give me like a newsletter as if the New York Times will send us this to me. Wow, how did it go with Indian politics? That's so interesting. Yeah, very interesting. We can make it even more focused, actually. So I have a prompt that done like, just to check of what happens on X, and basically we check the post every day on about Toolhouse. So let's do this again. So basically what I'm telling is just like get tweets about Toolhouse and myself and my co-founder and our developer advocate, and then read each tweet, categorize it into like positive coverage, negative coverage, and request for help. And then can you send me a digest? So we had this running every day, every morning, and we don't have to pay for any like sentiment analysis or like tweet monitoring solution. It's just Toolhouse every day, 12 cents. There you go. So now it's doing the analysis, and you're going to see, hopefully, an email there. And so those are like small nuggets that you can just do with a prompt. So I was like rolling the dice one day, and yeah, one of the use cases was about X and like getting sentiment analysis on a brand or something I liked. I was like, yeah, I like Toolhouse, so let's do it. And so, woohoo! It's a ton of positive coverage. Nice. And so now it has prepared an email. So who was the person who asked me about AI being able to write its own tools? That's basically what's happening right now. There you go. And so, oh, I see one email. There you go. That's our. Somebody, oh, there you go. Yeah, I woke up this morning to this. So, just so you know. All right. So that's like one of the small ideas you can build, but those are ideas that, like, I used to work at Twitter, and there were like a bunch of sentiment analysis companies that charge like hundreds of thousands of dollars a month. Like, you can do your own now, and it's all and so for everybody. So that's one of the many things you can do. Another thing is, let's see, I have the image generation here. Can you generate an image of Toolhouse and its team, given what you just read? It's like very chaotic. But this shows you that, like, Claude, for example, which we have behind the scenes, like I said, is not able to compile images. Imagine, how do you actually plug an image model into a text generation model? Oh, there you go. It even spelled it correctly. Oh. That's a bigger team than we have today, but, you know, getting there.
I'm disappointed it's missing the chippy chap.
It's us losing focus and productivity to look at that tweet, as you can see. But so you get it. Like, you can now combine these things without worrying about its implementation. It just works. So all you have to do now is to copy paste this prompt that you just like put, like I did before, package it into an app, run a cron, done. That's your app. Put a Stripe link, maybe, if you want to monetize it. And that's pretty much it. So 3 minutes demo, 4 minutes demo, yeah. And
Yes.
do I have time left?
No, you had 5-minute timer already.
Oh, coming soon, browser payments.
All right, Hasura, PromptQL.
Doesn't go up. Okay. Perfect. So let's start with what does not work. So we realized that AI assistants, AI agents in closed enterprise domains with real user queries just don't work. Let's look at one example of a decently big player. They have this new assistant working on Salesforce. I'm assuming everyone has heard of Einstein or the Agentforce rebrand that they've had. We asked it a very simple question. What is the average length of our sales cycle this quarter? Simple question. You should be able to look at the Salesforce data. That's what you're supposed to do and give me an answer. Says, sorry, I can't answer that question. Like, okay, try again. Okay, cool. The answer is 2.21 days. How, why, where, when, no idea. It's just 2.21 days. Which sales cycle is ever 2.21 days? Right? Which, we are an enterprise company, enterprise software company. 2.21 days is just plain ambitious. So you asked it, can you explain how you got this number? And it says that, okay, I took the average of the stage 1 to stage 4 age length field from the opportunity object. Sure. First of all, we have 7 stages, not 4. Even if we had 4 stages, this 2.21 number is just not correct. Even from deal to go from stage 1 to stage 4, it takes a couple months. So this is fundamentally wrong. What we wanted AI to do was, if we ask a question like, same question, what's the average length of a sales cycle? First think, right? What does a quarter even mean? Determine the current quarter start and end dates. If I realize that you said, okay, the quarter starts in September, ends in December, right? No, but my financial quarter arbitrarily starts in November. I should be able to tell you that. Then I'll query the opportunity table for closed opportunities, both won and lost. Okay, you're smart enough to understand that opportunities can be both won and lost in the current quarter. Then I'll calculate the difference between the created date and the closed date for each opportunity. So I'm going to run this loop. And then I'll calculate the average of the sales cycle length. So, and then give you the answer, right? That's exactly how a human would go about answering this question. Comes up with an answer saying 214 days. Unfortunate, but still correct. So that's why we want to build a new way, a framework, a new type of agent that connects any data source that you might have to your LLM, whatever LLM you might have. So loved the DBOS demo on customer support. So let's stay on customer support. So this is an assistant we built for our internal customer support teams. So it's connected to a bunch of our customer data, which sits in BigQuery, our product usage and metrics, our billing data, our finance data. It's also connected to our ticketing system, which is Zendesk. So it's connected to a bunch of different data sources. And now my agent, my customer support agent can come and log into work in the morning and ask either a very specific question or a very vague question. Vague or specific? What do you want to start with? Specific. Okay. So specific question means that there can only be one answer to it. I want my AI to be deterministic in answering that question, right? So something like, who are my top 5 customers by revenue? That's easy. Let's make it more difficult. Who have at least 4 projects with us? So that's one data source, it's coming from BigQuery. Who have and at least 2 support tickets? So let's make our AI join data across BigQuery and Zendesk. So 2 support tickets. And let's make it do some complicated math, like average and at least $7,632 average revenue per project. Very specific question. Can only be one answer to this question, right? What does PromptQL do? It says, okay, first I'll get all your customers and their projects and filter those with just 4 or more projects. Fair enough. Narrow down your search space. I'll calculate revenue per customer from invoice item. Okay, it's smart enough to figure out that revenue data doesn't exist anywhere. It's smart enough to understand that, okay, I need to probably club together all the different, I'm going to zoom out a little bit. Yeah. So I'm going to calculate the revenue per customer from invoice items. So I'll group every invoice item per customer and then do a sum to identify which customer has the highest revenue. I'll count the support tickets per customer. I have to go to Zendesk for that. I'll combine all this information, who meet all this criteria, these 3 criteria, average revenue per project is at least 7,632, and then sort by total revenue and get you the top 5. And it gets me the top 5. These are my 5 customers, number of projects, support tickets, average revenue per project. Seems correct. Now, what if I want to ask I'm 5 minutes over?
You're at 5 minutes.
Damn.
Ask a vague question.
Vague question. Okay.
Show us something vague.
I'm gonna ask. That's a great question. Actually, I want to ask this question now. Who is your favorite customer? Okay, vague question. I want my AI to be opinionated. I've never tried this question. Okay. One question I have tried, which works like this, is who. But who are my 5 most pain in the butt customers? Okay, let's see what it does here. Let's see what happens to those guardrails. Okay, so potentially challenging customer is how it's translating it. I'll create a scoring system that considers number of support tickets, priority levels, invoice payment issues, frequency of support interactions. I'll calculate a composite score for each of these customers, and I'll give you. But, okay, there was an error assessing this. See, this is what I want my AI to do, right? If you mess up in your analysis, figure it out what the issue is. Okay, so a standard date arithmetic was the problem. So it was assuming some datetime function it was messing up with. It came up with a new approach, implemented that approach, executing. These are my 5 most pain in the butt customers.
Nice.
Okay.
Nice.
Thank you. No questions?
Quick question. How long do those memory artifacts persist?
Only in that thread. Okay. So, yeah, it's up to you. You can delete them when the thread is over, or if you persist the thread, you can also choose to persist the artifact.
Okay, so there is a way to persist them.
Yeah.
Okay, we have one surprise demo from Brooke from Cobol. Brooke, you're going to have to do this real fast because we're going to get kicked out of here in 5 minutes. Not only is your your demo going to be over in 5 minutes, or we're going to have to get kicked out? So 4 minutes now.
I will be so speedy then. Cool. Hey everyone, I'm Brooke. I'm the founder of Koval, and we're a simulation and evaluation platform for voice and chat agents. So who here has built a voice or chat agent? Yeah. You know how annoying it is to manually go back and forth with your voice agent and make sure that it's doing what you expect. You make a change to your prompt, and then you have to call it 10 times to see if it like works every single time. So this is super time consuming. I think we've seen even at really large companies, like the engineering developer productivity goes way down because everyone just has to spend an hour calling their voice agent every single day. So what we do is, that is my code. What we do is that we simulate thousands of conversations so that you don't have to. And what we can do is, so like for any conversation, we can actually look at, like simulate this conversation back and forth. So you can see that where our simulated user is talking to your agent. And we can do things like show sentiment analysis. We can also show tool calls. So for example, reloaded. Yeah, so we can also show tool calls so that you're able to see like when the tool calls go wrong. For some reason, it just reloaded. So yeah, so we can show you like, okay, these are all the tool calls that were correct and all the tool calls that are incorrect, so that you don't have to scan through tens of thousands of JSONs. And then we can also do things like doing workflow analysis. So, sorry, my Wi-Fi is really slow. Yeah, so we can do things like map out how many calls you've had, look at all of the different pathways through your calls, be able to do topic analysis, etc. And so one thing that we're doing is basically taking a lot of the learnings from self-driving, because I was previously at Waymo where I led our evaluation infrastructure team. So we're taking a different approach to analysis, which is instead of looking at any one of these examples, how can we look at thousands of examples and see how often certain types of events are happening? Like, how often are we seeing like background noise, or how often are we seeing hallucinations, instead of saying for any one example which ones are incorrect. We can also chart pathways and then like dig into any one of these and see what exactly is going wrong. So that's like a super speedy demo. Yeah, come talk to us if you have any questions.
Thank you very much for getting that done before 8:30. I recognize that was a very fast demo. Okay, so it's 8:28. The cleaning team is going to be here in about 2 minutes. So as fast as you can, get out of here. Thanks for coming by, man. Thanks for hosting. Yeah. Let me know the next time you're back in this up. I'll ping Drew Shuck about finishing up our current project.